In this video, we're going to learn about the pH scale and indicators. The pH scale is a way to give you a measure of how acidic or basic something is. And the way we measure that is by looking at the amount or concentration of the hydrogen or hydronium ion, in other words, the H+. So we use a pH scale to basically tell us if something is acidic, basic, or neutral. And the pH scale will range, if you can take a look over here, this is the pH scale. It ranges from 0 all the way to 14, from 0 to 14. And the way it works is that any pH that's less than 7, so even if it's 6.9, 6.8, any pH that's less than 7 is considered an acidic solution. And that means that my H plus is greater than my OH minus. The lower the pH is, the more acidic something is. So for example, if I had a pH of 0, that is more acidic than a pH of 1. If I had a pH of 5, that is more acidic than a pH of 6, but less acidic than a pH of 4, because the lower the pH, the more acidic something is. If you had a basic solution, the pH is greater than 7. So 7.1, 7.2, 7.3, 8, 9, 10, 11, 12, 13, 14, those are all basic. And basic solutions, your OH minus is greater than your H plus. The higher the pH, the more basic your solution is. Finally, if you have a pH somewhere in the middle of that scale, so pH of 7, then you're considered neutral as a solution. You're neither acidic nor basic, and your H plus concentration is equal to the OH minus concentration. Now, here you can see on the scale some examples of different substances and where their pH lies. So for example, milk altogether as a solution has a pH of 6, which means it's slightly acidic. Whereas eggs, if you were to analyze them as a solution, have a pH of 8, so slightly basic. Then you get more basic, so baking soda is 9. And that makes sense. Baking soda, if you analyze its formula, it's NaHCO3, and that's one of the bicarbonates. So it's basic. Now let's go take a look at that scale, what those numbers mean. The scale for a pH scale is actually considered logarithmic, or we can say log for short. It's a log scale. And what that means is that each unit, each pH unit, actually doesn't represent a difference of 1. It represents a difference of a factor of 10 times. So for example, if I'm comparing a pH of 3 and a pH of 4, okay, the pH of 3 has actually not 1 more H plus, but 10 times more H plus, because it's 1 unit difference, and each unit is 10 times, not 10 plus, 10 times. So for example, let's say I was comparing a pH of 3 versus a pH of 5. So first of all, the more acidic one is a pH of 3. How many times more acidic is it? Well, the difference between them, 5 minus 3, is 2. It's not 2 times more acidic. It's actually 10 times more acidic, which is 100 times more acidic. You can also look at it like this. You can say 10 to the power of 2 times. So whatever the difference in the pH is, do 10 to the power of that difference, and that's how many times more acidic the lower pH is. So we'll try a sample problem out together. You can try it yourself first to see if you understand the concepts, and then you can pause the video, then unpause it, check your work. So substance A has a pH of 5, and substance B has a pH of 9. Which is more acidic, A or B? Explain. So hopefully you selected that A is more acidic, and that's because it has a lower pH than B. In fact, B is basic because it's a pH of 9. A actually is acidic, pH of 5 below 7. How many times more acidic is the most acidic substance compared to the least acidic substance? Explain. So in other words, how many times more acidic is this pH of 5 compared to this pH of 9? So you know that the difference in pH is 9 minus 5, 4. That means that the pH of 5 is 10 times itself 4 times, basically. So 10 times 10 times 10 times 10 times more acidic. This you could have just written as 10 to the power of 4 times more acidic. So essentially, you're looking at 10,000 times more acidic, more H plus, compared to the pH of 9. Because 10 times 10 is 100, times 10 is 1,000, times 10 is 10,000. Or in other words, 10 to the power of 4, 10 to the power of that difference. And that would be how you could compare acidic and basic solutions to each other based on their pH. Now, how do you get those numbers in the lab in a real practical situations? Because you will have to do that in grade 10. You will learn how to measure the pH of a substance in the lab. And it's actually quite simple. There's a few different ways you can do it. One thing you can do is use what's called a pH meter. It's just basically a fancy device connected to some kind of like computer, digital device. You put the probe into the solution and a reading comes up. So that works. Those are expensive though. They break sometimes, so you won't always be using them. They're not always necessary. It is nice to have them when you're trying to collect a lot of data really quickly all at once. But if you're just trying to deal with one solution at a time, you can use something else called an indicator. So acid-base indicators are substances or chemicals that change color in the presence of an acid or a base. So in acids, they're one color, but in bases, they're a different color. In fact, even a lot of the indicators are actually natural indicators. So if you look at certain flowers, some flowers like hydrangeas will be a certain color in acidic soil and another color in basic soil. So you can look that up, and it's kind of neat to see that based on the color of the flowers that come up, we know a little bit about the acidity of the soil there, which is a good indicator for whether other plants can grow there or organisms can live there. So there's many types of those chemicals that we can use, and you'll use them depending on what your substances are. But one indicator is called litmus, another is called universal indicator, another is called phenolphthalein. So these are all different types of indicators that you can use. The common one that we're going to use in the lab is litmus paper. There's two colors, there's blue and there's red. And they're actually extracts from a plant put onto a strip of paper. And they actually look like this here. So you have this little strips of paper like this, blue or red. And you essentially use them together. So if you have red litmus paper and you put it into a base, it becomes blue, base blue. If you have blue litmus paper and you put it into an acid, it becomes red, acid, red, acid, red. Now, the interesting thing is that blue litmus paper will stay blue, blue litmus paper will stay blue in a neutral solution, and red litmus paper stays red in the neutral solution. So you can take a look over here. Here we have red litmus paper. It turned blue in a base, but stayed blue in a base. Here we have red litmus paper turned blue, but blue litmus paper stayed blue. Here we have red litmus paper in an acid. This stayed red. Here we have blue litmus paper in a base. This became red. So the blue litmus paper becomes red in an acid, I should say. The blue litmus paper stays blue in a base. The red litmus paper becomes blue in a base. The red litmus paper stays red in an acid. So now, how do you identify if something is neutral or not? Because if I have a piece of red litmus paper and it stays red, well, that could mean that my substance is an acid, but it could also mean that my substance is neutral. So that's why it's important that I test the solutions out with two pieces of paper each. So if something stays red, but then I take the blue and it becomes red, I know it's acidic. If something stays blue, so blue stays blue, but I take the red and it becomes blue, I know it's basic. However, if both papers stay the same color, so red stays red, blue stays blue, then I know my solution is neutral. Okay, so you do actually need to memorize the color that litmus paper would change. Okay, so blue becomes red in acids, red becomes blue in bases, and then both of them stay the same color in neutral. Because this is a common indicator that we'll use and you should know how to use it without having to look it up every single time. Another indicator that we'll sometimes use is called the universal indicator. So litmus paper, you could really only tell if something is acidic, in other words, pH less than 7, basic, pH more than 7 or greater than 7, or neutral, pH is equal to 7. Sometimes we want to have a more precise value, an actual number for our pH, and what you can do is you can use the universal indicator instead. And the universal indicator works in a similar way. You have a strip of paper, but instead of just having the litmus chemical on it, you have a mixture of chemicals on them that change a variety of colors at a range of pH values, not just pH less than 7, more than 7, or equal to 7. So what you do is you just dip your pH paper into your solution that you're trying to test, and then it'll change colors. You match that color to a color on a chart that will be given to you. You don't have to memorize that chart. You just have to know how to use it. And then you can use that to figure out what your pH is. So about a pH of 2, for example, for this one here. So it's a more specific pH compared to an indicator like litmus. Another type of indicator I mentioned earlier is phenolphthalein. This one over here is colorless in acids, and then this pink color in bases. And we've seen that in demos, but this is a good one to memorize as well because we will be using this quite frequently. So you should know how to use universal pH paper. You should know how to use and memorize litmus paper, and you should know how to use phenolphthalein as well and memorize that color change. There are other indicators that exist. You won't have to know how to memorize those, but if I gave you, for example, the ranges that they change color at, you should be able to tell me if a substance is acidic or basic with some observations and the information about their color change. So in this video, we saw the pH scale, and we also saw how to measure the pH using a variety of different indicators. In your lab, you'll be measuring the pH of different substances, household substances, using some different indicators.